now submitted. I think I had a few days to complete it before. I hope you sat down and completed it because it's an exact level of difficulty of the midterm. Okay? The quiz is an exact level of difficulty of the midterm. So once you see the midterm, once you see the quiz, you will see that it's an exact, it's distinct. Okay? So I encourage you. It was fair, I think, no? Was it fair?
Yeah.
I think it was more on the easy side than on the hard side, the quiz, but, and I think you should expect this for the midterm. Okay? Great. So let's continue where we left off last time. What is the last thing we've seen? The tangent plane. So let's do some exercise on the tangent plane. I'll be using now stewards in this. Okay. Or maybe let's do one more notation. Before I do that, notation. You have seen that. Okay, everybody. Okay, are we good? Yeah. We have seen that if fxy is a differential function of x and y, the derivative with respect to x is denoted by f sub x and y or f1 xy. y1 meaning it's a derivative with respect to the first argument. Okay? Yeah? Another notation for that is del f xy. Okay? Del f divided by what? Del x. Right? Instead of df dx, we denote it by this type of d. Okay? Del the d is curved. Okay? Great. So let's give an example. Find del z del y. So del z del y means differentiate z with respect to y. What is del z del y? Del z del y. Anyone can help? Who can help? Volunteer. So let's take this x out. Y squared equals 2y. What's the derivative of this one with respect to y? It's 2y e to the y, right? Plus the y squared plus squared. Okay, are we good here? Is that clear? Any questions on this? Any questions? Is that clear? This is just notation, means the derivative of z with respect to y. Okay, what's del z del x? Differentiate this with respect to x, what do you get? Ey y squared plus 2xy. Okay? Are we good here? Yeah? This is just notation. Okay. Then afterwards I want you to be careful with the notations, we'll see why. Okay? And let's recall. An equation of the tangent plane to the curve To the surface, sorry. To the surface. Z is equal to fxy at the points x0, y0, fx0, y0. Assuming f is differentiable there, what is it? What is it? Fx x0, y0 times x minus x0 plus fy x0, y0 times y minus y0. Yeah?
To the screen.
Oh, okay.
Just, yeah.
Is that good?
Yeah, like.
What do I do here? What should I do? Minus z minus z0, right? Minus z. Okay? Did we see this before? We saw this equation before, right? We saw this before? This is where we finished last time. Are we good here or not? Are we good? How do I make sure that I'm correct? Let's plug in x0, y0, and z0. Well, I mean, that might not come right, because you also get 0. Well, yeah. But what's the normal vector we got? Remember, what's the normal vector we got? Fx, Fy, and 1 or minus 1? Fx, Fy, minus 1, right? You remember this or not? No? We don't remember this? What's the normal vector we got to the plane, to the tangent plane? Fx, Fy, and minus 1, right? So this is the equation. You guys see this? Do you remember this or not? Should I remind you what's the normal vector? What's the normal vector? A normal vector. Two. Then equal fxy and what is it? What is it? Yes. Minus 1. You remember how we derived this? We took two curves, we sliced the surface when x is equal to a, and we looked at this curve, right? Remember this or not? To find one vector in the plane. And then we sliced the surface when y is equal to b to find another tangent. And then we took the cross product of the two vectors. And that's what we got. Remember or not? Yes or no? You remember the last time result? This is where we finished. And then we derived this equation. We had it this way this time, or we had minus 1? What did we have? Why did we have it that time? We had minus 1, or 1, or this one. I mean, even if you had minus, and plus 1, it wouldn't change, would it? It's the same direction. It's the same line, basically, just quoting different ways, basically. Okay? Are we good here? Great. Let's do examples from the book and start doing equations. I mean, one of the easiest questions in Calc 2. Find the tangent line to the curve and find the normal line to the curve. Those are the easiest questions in Calc 1. So these were the easiest questions, right? Find the tangent line to the curve at the point a f of a. This was easy. So we're going to do the same thing here. Those are the easiest questions in calculus 2. Okay, so find the equations of the tangent plane to the surface z equal fxy at the given time. Okay, so let's pick some examples. 2x squared plus y squared minus 5y. Okay, so how do we do this? What's the first thing we do? What's the first thing we do? Find fx and fy. Very good. Are we good here? So what is del z del x? What is that? What is that? 4x. What is del z del y? It's 2y minus 5 by 2. Then, what is del z del x? Oh, let's write here xy. Okay, let's write here xy. Although usually people don't write it this way, but that's fine. What's del z del x 1, 2? It's 8, right? And del z del y 1, 2, what is that equal to? Everybody, what is that equal to? Minus 1. So what's an equation of the tangent plane? What's an equation of the tangent plane? Did I mess something up?
Isn't it 4?
Oh, where? 4y. Oh, shoot, it's for x here. Thank you. Thanks. Thank you. Then what's an equation of the tangent plane? 4 times x minus 1, right? Plus or minus y minus 2 minus z minus minus 4 is equal to 0. So, yeah. Are we good here or not? Are we good? Yes or no? Yeah. Derivative with respect to x at 1, 2 times x minus 1 plus derivative with respect to y at 1, 2 times y minus 2 minus 1 times z minus 4. So what do you get? You get 4x. And you can keep it this way. I don't want to keep it this way. Okay? Are we good here or not? Is it clear? We do a few more? We do a few more or not? Is it clear or not? Yeah? This is just the equation of the tangent line. You take f prime of a times x minus a plus f of a. Here, instead of the tangent line, how many derivatives you need to take? 2. Okay? Let's do one more. Well, actually, let's do a few more. Surface z equals fxy, where fxy is equal ex minus y at the point where x is equal to and y is equal to 2. Do you guys want a minute to work on this, or I should just go ahead and do it? I'll go ahead and do it. Great. So let's see. And you can work at the same time with me as well. So how do I do that? How do I start? I need to differentiate f with respect to x and y. Very good. So what's the derivative of f with respect to x? Who can help? What's the derivative of f with respect to x?
E to the x minus y.
It's e to the x minus y. What's the derivative of f with respect to y?
Negative e to the x.
Negative to the x minus y. Great. Now, is there something missing here? I have a normal vector. I could compute it. But is there anything missing? Z is missing, right? At the point 2 and 2. How do I find Z? Can I do it? Plug in, exactly. Right? So if x is equal to 2 and y is equal to 2, what is f2 2? Everybody? 1. So what is the point of the surface for which x is equal to 2 and y is equal to 2? 2. What is the z value? 1. So I need to find the tangent to the curve at what point, to the surface at what point? 2, 1. Are we good? Everybody, are we good? Yeah? Okay. So what do I need to find here? I need to plug in. That's x. What is f of 2, 2? This is 1, right? What is fy of 2, 2? What is that equal to? Minus 1. So what's the equation of the tangent plane? What's the equation of the tangent plane? So 1. Yeah, please go ahead. Don't hesitate. Yeah? Yeah?
Y minus 2.
Very good.
And then minus z minus 1.
So z minus 1 like that, or I have brackets somewhere?
Right.
Okay, let's look at this. Let's rearrange this. It's easy to rearrange. So this is x minus y minus z. Minus 2 plus 2, what is that? 0. Plus 1 is equal to 0. So if x is equal to 0 and y is equal to 0, z should be equal to 1. This is nice, actually. This is nice, actually. You see why it's nice? You guys see why it's nice? If I ask you what's the tangent plane at the point 3, 3, if x is equal to 3 and y is equal to 3, what is the tangent plane? It's going to be the same. Right? If I tell you, if x is equal to 3 and say x is equal to a and y is equal to a, what is the value of z? 1. Now, will the derivative stay the same if x and y are equal? Yeah. So z is the same if you see this? This is a very nice question, for example. So at what points, or show that if x is equal to, so show that for any value of a, the tangent plane at the point a, FAA, which is 1, has this equation. Would it depend on the value of A? No. Okay? You can expect a question like that on the final. Okay? Something of this caliber. Not very hard, but just test your understanding. Okay? Should we do it? Should we write this down like that? Let's write this down. I mean, it's show that the tangent plane with the surface z is equal to fx1, where what? Where fx1 is equal to x1 at the point FA is it's fine. That's fine. Show that an equation of. Okay? Should I do it? I mean, it's clear here. You agree or not? Is it clear or not? Or should I do it? Today you guys seem very calm. Usually you're more active. Should I do it? Very good, let's do it. Why are we tired today? Weekend? Want to stay? You had to work a lot, I think, in physics. Okay. Yeah, I mean, we still have how many weeks? 3 more weeks? 3 more weeks and we're done. So we can, you know, it's done. But anyway, let's differentiate this. What is that? It's, well, the same. It's minus, it's minus y. Now fx at AA, what is that equal to? This is 0, which is 1. And fy at AA is equal to minus 1. So what is an equation of the tangent plane? It's 1. Who wants to help? Who wants to help? An equation of the tangent plane. Who wants to help?
1 times x minus a.
Yes.
Minus parentheses y minus a.
Yeah.
Minus in parentheses b minus 1.
It's equal to 0. So x minus a plus a to 0. So x minus y plus z is equal to 1. Agree? Everybody? Does the tangent plane depend on a here? No. Okay.
Is it minus this?
Where? Oh, true. Plus 1 is equal to 0. Okay? Did I mess anything up? I don't think so. Is that good? Any questions? Why it's 1 here? Is that a question?
Minus that, or plus that?
Minus that. What am I saying? Did I have it correct? Yeah, thank you. And why is it minus 1? Why is here 1? What is FAA equal to? FAA is equal to 1, right? Okay? Questions? Questions? No? Awesome. We do one more, and that's it. We do one more tangent plane. Let's see. Okay. Let's do this one. Do you want to take a minute to do it? Okay, so please take a minute. This is not a minute to discuss. This is a minute so that you can try the problem on your own. So, we're done or not? We're done? Done? Great. Awesome. Great. So what do I need to do first? I mean, there are many first steps that you can take, but let's find what do I have missing here? The z value, right? What is the z value in that case? 0, right? So if x is equal to 2, if x is equal to -1, then z is equal to -1. Okay, great. So I found my point, I found x, I have x and y, and then I found z. How do I differentiate? Well, what is the next step? Find fx and fy. So I'll call it del z by del x this time. What is del z del x? Someone? Yeah? Yeah.
X plus y.
Sin x plus y, yeah.
X plus y.
Lots of x times.
Plus x.
Very good. Who wants to help me with del z del y? Someone else? Yeah?
X plus y.
Del z del y is x cosine x plus y. Thank you. So what do I need now? At what point do I need to find del z del x? At what point do I need to find them? 1 minus 1, 1. Thank you. Minus 1, 1. What is that? What is that? Minus 1. And what is that y at the point minus 1, 1? Yeah? Did we get this? Did you all get this or not? Yeah? Okay, so please participate. It's a sign that you're doing good. If I feel you're doing good, it means less homework, right? So, homework I just made to make sure that. Anyways, then that's del y is minus 1, 1. So, how do I find the tangent plane now? An equation of the tangent plane. Good morning. So who volunteers? Someone else? Yes.
Okay, my expression.
The tangent plane. Minus 1, 1, 0 is, yes.
Minus correct.
Yeah.
X plus 1.
X plus 1, thank you. Then?
Bracket, minus x, minus bracket, y minus 1.
Yeah.
Full bracket, and y minus c. Oh, no, minus c.
Okay, is that?
Yeah.
Everybody, are we good? Okay, we can expand that. I mean, you can put this into pluses. What do you get here? What? Y plus 1. No, y is minus 1. X is minus 1, y is 1. Okay. So what do we get? You get minus x minus y. Well, I mean, let's put pluses here. So you get x plus 1 plus y minus 1. So what do you get here? X plus y plus z is equal to 0. Minus 1 plus 1. Okay? Are we good? Is it clear? Yeah, just differentiate. Just differentiate the thing and that's it. Now, what did you use the tangent line for? Remember, let's look at the things from calc 1 until now. We start with the tangent line. What did we use it for? What did we use it for? What was the goal of the tangent line? There is something that we call the tangent line approximation. So I can use tangent line to approximate the value of f of x if x is near a, right? Great. This is calc 1. Now in calc 3, what did we do after the tangent line approximation? We did Taylor series, right? Taylor series, if you take the degree 1 term of the Taylor series, you get the tangent line approximation, right? F of a plus f prime a times x minus a plus f double prime a over 2 factorial times x minus a squared. So the first two terms, the degrees at most 1, the terms of degree at most 1, form the tangent line approximation. In calc 3, we're going to do the same thing. So, instead of a tangent line approximation, what do I have? A tangent plane approximation. And then, we also have power series in 2D. Isn't that nice? It's very nice. Power series in 2D, they're going to be very useful. But, we have to define the derivative in other words. What's the second derivative really here? If I take a second derivative, do I have to differentiate twice with respect to x, twice with respect to y, once with respect to x, once with respect to y? How do I define my second derivative? Okay, so this is going to be very important. We're going to do power series in 2D. I don't think I'll do the full extent of it. I'll just do the first the degree 2/3, basically. It's a quadratic approximation. I mean, usually it's not done in concrete, but it's part of the program, so I'll do it. It says on the syllabus, Taylor series in one and several variables, so I'll do it. But usually it's not done. But even if it's not done, doesn't mean it's not part of the curriculum. So we'll do it. Okay? Great. Awesome. Now let's start with the tangent plane approximation. In calculus 1, you have f of x can be approximated by f prime of a times this one, right? Agree or not? What did you call this? The tangent plane, tangent line, sorry, approximation, or the affine approximation, or linear approximation, whatever you want. Okay, now in class 3, what are we going to do? So I have fxy, if x close to a. fxy, what is that? How can I approximate this? If x is near a and y is near b, or if xy is near a b. So I can approximate it by an equation of the tangent plane. So what is that? Just fx ab times x minus a plus fy ab times y minus b plus f. Okay? Everybody, do we agree? If you take this, if you take z equal to this, you get the tangent plane, right? Take z is equal to this thing, what do you get? Do you see that?
Yeah.
You get a tangent plane. Just bring the z to the other side, and you get the tangent plane. Okay? See if the book has questions on this. I think they do. Okay, and the function. Lxy. What did we call this type of function in Calc 1, other than the tangent line approximation? We called it linearization, right? Did you see this word? Linearization of f at a. Did you see this word or not? No? That's fine. If you didn't see it, it's called linearization of f at ab. We good? Yes. Let's give an example. Can I erase here? Is that okay? ahead. Okay, this is the last. We will not do tangent plane. We will go to the chain rule immediately afterwards. Okay, so it's going to be more serious stuff. So benefit from this to work on it a bit. So what are my 2 points? What is the suitable point here? 3, 4. Oh, very good. That's the first step. Okay. Okay, so I'll pass by if you guys wish to ask questions. I'll pass by as well. Okay. Please work on it. And leave your answer, if possible, in terms of fraction. Okay? An irreducible fraction. I'll be there if you have questions. Are we good? Do we need more time, or are we done? Okay, so one more minute. We're done? Okay. 30 more seconds. Okay, let's get started. So first of all, what is the point I need to choose? What's a good point to approximate these two? To approximate f3.01 and 3.99. 3.4. Great. Now, in order to approximate f3.4, I'd better have f3.4 to have a nice form, right? I'd better have something nice when I compute f3.4. Let's double check. So approximate. By tangent plane. At 3, 4. What is f of 3, 4 here? F of 3, 4 is 5, right? You agree? 5 things. Okay, now what is the tangent plane to fxy at the point 3, 4? What do I need to find? The derivative with respect to x and the derivative with respect to y. So what is fx? xy, this is just x over square root. Right? Is that what we got? What is the derivative with respect to y of fxy? Did you expect that or not? Y. The function is symmetric in x and y. Right? If you flip x and y, you still get the same function. Now it's easy to differentiate this one. But in general, if you can flip x and y and the function is symmetric in x and y, you can do this with derivatives. Okay, but anyway, let's not worry too much about that. Basically, the derivative of x at yx will be equal to the derivative at y at xy. Anyways, don't worry about that. That's not a problem. Where, at what point, so how can I approximate f3.01, 3.99? Well, that's right here. So, I need to compare the point 3, 4. So, fx 3, 4, what is that equal to, everybody? It's 3 over 5. And what is fy at 3, 4? 4 over 5, thank you. So, f3.01, 3.99 is approximately equal to what? Do you want me to write the expressions first, and then I plug in the numbers, just to be easier? So it's fx 3, 4 times x times 3.01 minus 2, right? Yes. Plus fy 3, 4 times 3.99 minus 4, right? Agree or not? Yes or no? Plus what? Did I forget something? Plus 5. Very good. Plus f3.4, which is 5. Someone said f3.4, right? So what is f3.4? 5. Okay? Great. Now how do I write this as a fraction? So this is 3 over 5 times, what is this as a fraction? 1 over 100. Plus, well, this is 4 over 5 minus, what is it in a fraction? 3.99 minus 4. Thank you. Plus 5. Great. So it's 3 minus 4, which is minus 1 over 500. Plus 5. Are we good here? So it's 2499 over 500, right? You see that? minus 1 plus 2500 over 500, which is just 2499 over 500. Okay? It's still not very far. No, it's still far. It's just 1 over 500 away far by this linear approximation. Okay, it may be further. But okay, are we good here? Okay, so again, imagine if you had expanded all of this without plugging this in. You would not be able to find the nice expression. Okay, so it's better to use the x minus a and the y minus b, right? So that immediately you can simplify it to a fraction. Are we good here? Yeah? So this problem you can do without a calculator, technically. Okay, did we need a calculator? No. Okay. Great. Should we do one more on linearization, or that's fine? We do one more, or that's fine? Everybody, so please let me know. We do one more on linearization, or that's fine? It's fine? Very good. One more? Let's do one more. Find the linear. At 0, 0. Of fx squared. Okay, so what is LXY in that case? LXY. So first, what do I need to do with M? I need to find the value if x is equal to 0, y is equal to 0. What is this value? F0, 0 is equal to 1. Great, what do I need after? I need to differentiate with respect to x and with respect to y and plug in 0, 0, right? What's there with respect to x? So it's e to the x cos xy, right? Minus y e to the x sin xy. Okay, are we good here? Yeah? Are we good? Then what is fy xy? So I differentiate with respect to y, so I get minus x e to the x sin xy. Okay? Are we good? 100%? I plug in 0, 0. What's fx at 0, 0? What do I get? What? Yes, someone said it? What do I get? 1. And what is fy at 0, 0? 0. And f0, 0 is 1. So what is my linearization? This is just fx 0, 0 times x minus 0 plus fy 0, 0 times y minus 0 plus f of 0, 0. This is x, right? This is 1 times x minus 0 plus 0 times y minus 0 plus 1. So I get this x plus 1. Okay? Are we good? 100%? Great, let's move on to more important stuff called the chain rule in more than one variable. Okay, is this stuff okay? Linear approximation, things like that? Great, awesome. This part is easier. This part of the course is easier than the series, right? Or no? Yeah, it's easier. So we're just differentiating. We will just be maximizing, minimizing, chain rules, and things like that. Okay. Now I'll do chain rule first. I'll do the chain rules for first derivative, and then we can discuss higher derivatives. Okay. Great. Now, chain rules. I mean, there are many variations. Chain rule. Okay. In the calculus of one variable, we have seen that, let's say, I don't know, if f of x is h g of x, then what is f prime of x? This is just g prime of x, right? Times h prime at g of x. We agree? Yes.
What's the interval? This is an accurate approximation.
Usually near 0, 0. Okay, if I tell you approximate f 1000, you can see that it's maybe a better approximation. Okay. Great. So this is the chain rule in one variable. Now in two variables, I mean, you have seen one version of it. You have seen, well, it's really what we have done before. It's actually a chain rule in many versions. In one, we've seen something like that, right? So suppose that, this is not really the chain rule in two variables, but this is one of them. So, if I let gxy be f u xy, right, where f is a one variable function, so f is like cosine or exponential. What is the derivative with respect to g with respect to x? How did we do that? We differentiated u with respect to x, keeping y constant, right? And then I took f prime at uxy. Is that right? You remember this? We saw this last time. Yes or no? So imagine I want to differentiate cosine of xy. How do I differentiate this? I differentiate xy with respect to x, right? What is the derivative of xy with respect to x? It's y, right? What's the derivative of cosine? It's minus sine. That applied at xy. So it's minus y sine xy. Right? You see that or not? You see this? Differentiate this function while treating y as a constant and differentiate with respect to x. Derivative of the inside with respect to x is this one, times f prime at your x. All good? Any questions here? Any questions? Should we do examples or that's fine? We do one more, we do an example on this. Let's do an example. I mean, all of this is basically chain rule, right? All of this is well, it's this form of chain rule. So let's it's not the chain rule. It's not the chain rule we're after. Fine, I don't know. Let's see if the book has interesting answers. Well, let's do it. Okay, how to differentiate this with respect to x? I mean, this is what we've been doing all the time, right? How to differentiate this with respect to x? I differentiate the inside with respect to x. What do I get? Y squared. I take derivative of sine t. What's derivative of sine t? It's cosine t. Apply that x y squared, right? Is that fine? Is that good? Easy work, right? Okay, now let's go to a slightly more complicated form. Then we'll do the more complicated ones, but it's not very difficult, I guess. It's easy. It's actually very easy. I don't know if the book has this. I think it should. Yeah, I think it should. Great. Okay. Suppose you okay? Let f of t is equal to u g of t and h. F of t is a variable of how many functions? F of t is a variable of how many functions? F of t, F of t is a function of how many variables? X. How many numbers you plug in here to get? 1. Now u is a function of how many variables? 2. Right? So the question is that how do I find the derivative of f with respect to t? Now can I use the regular chain rule here? The regular chain rule says that this is the derivative of the inside times u prime applied to the inside. Does u prime make sense here? U prime, how many variables does u have? 2. So do I have a u prime? No, I have a u1 derivative with respect to the first argument, and I have a u2, a derivative with respect to the second argument. Do we see this or not? Now what is f prime of t here? Very easy. It's just a combination of both. Okay, I will not prove this. I mean, you can still prove it. It's not bad to prove it actually, but you can still do it. Derivative of the inside of the first argument. So this is g prime of t. Okay? Times. So with respect to which argument, so let's find the chain rule here in one variable. The derivative of that is this g prime of x, h prime of x. H prime of g of x. Let's try to apply the same reasoning here. We differentiate the inside of the first argument. You take it out. Now we need derivative of u, right? With respect to what argument will we differentiate u? To the first argument, right? So it's u1 plus h prime of t u2 okay, is the formula clear? Let's do it the next way. It says that if then it says, well, df dt, right? F is a function of how many variables? How many variables? 1. So df dt is equal to I think they use that word, but they use It's del f del x. I like this, that we're using f on both sides, but anyways. Del x del t, or dx t, plus del f del y, del y del t. Okay? Yes?
That's df over dt.
Where? Yes, this is df over dt. Exactly. Yes.
The last was it dy over dt?
Yes, dy over dt, not del. Thank you. It's or what do you prefer? I think I prefer to use du dt here. Doesn't matter. Yeah. Du. Okay. Because you have uxy. I mean, it's just this is a bit difficult. It's not difficult, but it may be a bit unclear in two variables. Okay, and I'm very picky on these. Like, you should specify at each time what the arguments are, if should there be any ambiguity. But anyways, let's try to do an example. Let's try to do an example. Let's see if the book has nice example. I think the book should have a nice example. Yeah. X squared y plus 3. So let's doesn't matter actually. And y is equal to cosine t. Okay, so the question is that find dz by dt in two ways. What's one easy way of doing it? And it's going to be ugly though. It's going to be very ugly, but anyways. Right, because you have to plug in the sine t and the cos t for the x and then differentiate. But that's fine, we can do that. What's one way of doing it? One way of doing it is just replace x and y by their functions in t. Right? So z is, what is z? Oh man. Sine squared, I should have put my own example. Anyway. Sine 2t squared times what? Times cos t. Plus what? 3x to the 4th. This is x. Sorry. Oops. No, that's right. Sine squared cos t plus 3 sine 2t to the 4th. How do you differentiate this with respect to t? How do you differentiate this with respect to t? Let's differentiate this. Oh man, it's a bit ugly. dz dt, what is that equal to? I think we need a big board. We need a bigger board here. We need a bigger board. So what is dz dt? First, if we differentiate cosine t and keep the other one fixed. So minus sine t times what? Times sine 2t squared, right? Plus cosine t, and you have to differentiate sine 2t squared. So how do you differentiate that? It's derivative of u squared. What's derivative of u squared? It's 2 u prime times u. So it's 2 times u prime. What's the derivative of sine 2t? It's 2 cos 2t, right? Times u, which is sine 2t. Okay? Plus 3. What's the derivative of sine 2t to the 4th? This is 4, right? Times u prime. What is u prime? It's 2 cos 2t, right? Yeah? Times u cubed. Okay? Are we good here? Did you differentiate this correctly? I hope so. Is this correct? Did I differentiate this correctly? 4 u prime u cubed. Yeah, no? Yeah, is that good? Great. Now, what's the other way of doing this? dz by dt is del z del x times dx dt plus del z del y dy dt. What is del z del x? Anybody can help me? Del z del x, differentiate that with respect to x, what do you get? 2xy plus 12x cubed times dx dt. What is dx dt? What is dx dt? It's 2 cos 2t, right? Plus, what is del z del y? It's x squared, right? Del z del y is x squared. Plus del y del t is minus sine t. Okay, now what do you have to do? You have to plug in sine 2t for x and wait, what happened here? I differentiated that with respect to x. Del z del x is 2xy, right? I forgot the y. Okay, now plug this in. Plug xy in. What do you get? You see, this can be more helpful. This can be more helpful. But look at the terms. So, or do you agree with this one or not? Okay, now plug in x equals sine 2t. Minus sine t, sine 2t squared, this is the term. You see that? When you plug in x equals sine 2t, this term is here. You see that? Now plug in del x del t. What is del x del t? This is 2 cos 2t. Yeah? And then plug in here. Look at here. So what do you have? You have 24. Here you have 24 cos 2t sine 2t cubed. Where do you have a 24? So 24, right? Cos 2t sine 2t cubed. Right? You see this? You see this or not? You see this, or should I expand it more? Should I expand it more? Do you want me to expand it more to see that you can convince yourself that you get the same answer? Let's expand it more. So, what is xy here? So you get 2xy, 2 cos 2t. xy is, so you get 4, let's do it here. 4 cos 2t. Yeah, so cos 2t, what is x is sine 2t and y is cos t. This is it, right? This term, 1. Here. You see that? Now, plus 2 cos 2t, so plus 4 cos 2t sine 2t cubed. Call this 2. 2. 12. This is here. And then what do you have? You have the other term, 3. Minus sine t x squared. What is x squared? Is sine 2t squared. Okay, it's the same answer, but one of them may be a bit shorter and more co-factorized. Let's do some examples. Okay, are we good here? Guys, are we good with this one? We'll just do no more examples, okay? Now, of course, you don't have to find it in 2 ways. You'll have to do it in 1 way. Find dz by dt. Hey, z is equal to what? xy cubed minus x squared y. X is equal to t squared plus 1, y is equal to t squared minus 1. Again, what's the same song that we'll sing, you know, on the chain rule? dz dt is del z del x times dx dt plus del z del y dy dt. What is del z del x? Everybody? Del z del x is equal to y cubed minus 2xy, very good. Then gx dt, what is that equal to? 2t. Then what? Del z del y, what is del z del y equal to? 3y squared x minus x squared. What is dy dt? It's also 2t. Are we good here? Yeah? Everybody, are we good? These are just derivatives. Are we good or no? Is it clear? No? Yes? No? Say. Yes, sir.
The dx dt
Is? Oh, this is t squared.
Yeah.
This is 2.
Oh.
Okay. Well. Next question. Find dy dz by dt when t is equal to, let's say, 2. Now, if t is equal to 2, what do I need to find? I have an expression dz by dt in terms of x, y, and t. Now x and y are themselves functions of t. So if I tell you find dz by dt when t is equal to 2, you plug in 2 for t, right? And what do you plug in for x? T squared plus 1. What do you plug in for y? Are we good here or not? Yeah? Folks, are we good? Yes? You did this in class 1, but in one variable, no? You said du by dx, dx by dt. If t is equal to I don't know what, then x is equal to this, and you, yeah? So if t is equal to 2, then what is x equal to? 5. And what is y? 3. And dz by dt, what is that equal to? Okay, so let's see. 27. So 3 cubed, what is 3 cubed? Is 27 minus 2 times 15 times 2t. What is 2t? 4. Right? Plus, what is y squared? Plus 3 times 9 times x times 5. Minus x squared. What is minus x squared? It's minus 25. That's not hard to do, I think. Minus 25 times 2t, which is 4. Okay? You can find this answer. Is that clear, or should we do one more? We do one more? Yes. Let's do one more. You realize why I pick questions from the book, because when I make up my questions, it's crazy numbers. So, it's but again, it's easy. So I could have picked t equal 1, would have been way easier. So the y would be 0. So I start picking by t equals 0. By t is equal to 0, the answer is silly, right? Because you get 0 here and 0 here. Then I said, okay, let's pick t equal 1. If t is equal to 1, y is 0. So that's silly, right? Because this will go away and this will go away. So I said, let's pick t equal 2, and it's a bit harder. But anyways. Okay, but this is, you're good, yeah. Let's do another one. Find dz by dt when t is equal to 0. If z is equal to x minus y over x plus 2y, x is equal to et. And okay, guys, let's go. Do you guys want to take some time to do it, or let's just do it together? We do it together? We do it together? Do I take a break of 2 minutes and chat? Yeah. Let's try to do it this way. Okay, so what is d by dt? What's my formula? What's my first formula? What's my first formula? dz by dt is what? It's del z del x times what? Times dx dt, right? So it's del z del x dx dt plus what? Del z del y times dy dt. Awesome. We got this? We got this, everybody? Okay, what is del z del x? write them all there. Let's write them all here. Del Z del X, what is that? I differentiate everything with respect to X while keeping Y fixed. So derivative of the top is 1, right? Times derivative times the bottom, which is X plus 2Y. Minus derivative of the bottom, which is minus 1. So minus 1 times X minus Y. Thank you. Over X plus 2Y squared. Thank you very much. Okay, so what do you get at the end? What do you get at the end? You get 3Y. Thank you. Okay, del Z del Y, what is that? Derivative of the top times the bottom minus the derivative of the bottom times the top over minus X plus 2Y. Okay, what is that? What do you guys get? What do you guys get? Did you guys do it? Minus 2y plus 2y, 9 minus 3x okay, is that good? Are we good here? Yeah? Is that clear? What is dx by dt? Is this good? Is the derivative good? What is dx by dt now? E to the t. What is dy by dt? It's minus e to the minus t. Right? So let's plug this in. Del z by del x. I need a volunteer to help me. Can anyone read for me del z by del x? What is that? 3y over
X plus 2y.
Thank you. And dx by dt is e to the t plus what? Minus 3. Oops, minus 3x over x plus 2y squared. What is dy by dt? Minus b. Thank you. And x, what is x equal to? X equal to the t, y is minus b minus b. Now if I ask you to find dz by dt at t equals 0, what is the value of t? T equal to 0. What is the value of x? X is equal to what? 1. Y is equal to 1. Okay. So at t is equal to 0. What is that? So you put 3 over 3 squared, right? Times 1 plus or minus 3 over 3 squared times minus 1. So you get 2 okay? Are we good here? Folks, are we good? Everybody, are we good? Let's do one more example. I'll do one more example. I'll pick a nice one from the book, actually. Let's go. So far so good? Everybody, do you find these examples help? Yeah? Let's do one more. So, and a somewhat different notation. Also from the book. By the way, do you all have the Stewart book from Calculus 2? You have the full edition, the full like multivariable and things like that. I mean, I think what I do in class is enough, and I'll be posting problems, but I'll also suggest problems, okay, from Stewart so that you can do them. Okay. Okay. Let PG be equal to F GTHD find P prime of 2 F G of 2 is 4. P prime is minus 3. H of 2 is 5. H prime of 2 is 6. Fx for 5 is 2. And Fy for 5 is 8. Everybody. Okay? F is a function of two variables. And I'm looking at P of t, which is f of g of t and h of t. P is a function of how many variables? 1. Let's do this. Who can help me with P prime of t in terms of, like, I don't want dels, I just want derivatives. I don't want del f by del x and things like that. Who can help me? What is P prime of t? Not necessarily at t equal to. Who can help me? What's the very first form we have written? I differentiate the first inside, the first argument, and I take it out, right? So it's g prime of t. Now, how do I have to differentiate f with respect to what argument? First argument, so it's fx or f1. I'll just use f1 here, doesn't matter. fx or f1? f1? Does it matter for you? No, it doesn't matter. Okay. f1 g of t, h of t. Plus, who can help me?
H prime of t. H prime of t.
Yeah?
Times f2g of t h.
Awesome. Okay. Now for what value do I need to find P prime? P prime at P is equal to 2. Great. What is P prime of 2? Who can help me? P prime of 2 is what? I'll just plug things here. It's G prime of 2. F1 G of 2 and H of 2. Try to just plug in. Okay. Now, what is G prime of 2? Everybody, G prime of 2 is equal to? G prime of 2 is minus 3. F1, where should I apply it? At what point? What is G of 2? 4. And what is H of 2? 5. So this is F1 4, 5. Plus, what is H prime of 2? 6. F2 at what point? G of 2 is 4. H of 2 is 6. Okay, what is that? It's minus 3. What is that? 1. So it's minus 6 plus 48. Is that right? So it's 42. Are we good here? Is that good? Should we do one more? I was trying to find one more, but I think just please 1 second. Yeah, no, we can find one. Anyways. Okay, is this clear? 100%? Now, what if, let's go another case of the chain rule. They call it the chain rule 2. It's a bit more general. But again, it's the same idea. Okay? And then we can do a 3 equation. Chain rule 2. Now suppose I have a function u x y. Okay? I have u, a function of x and y. Instead of x being a function of one variable, x becomes a function of 2 variables. And y becomes a function of 2 variables. So what do I have here? I just have u, f at t, g at t. Right? You guys see this? At the beginning I had x as a function of one variable. So the first one, x was f of t, and y is g of t. And then I had u f t, g. This is what I have. Do you agree or not? You remember this? And then this is a function of one variable that we differentiated. Are we good here? This is what we had at the beginning. Are we good or not? Do you agree with the beginning? Okay, great. Now, I'll write it in this form and then write it in the form del u del s. Or what do you prefer? You prefer the del u del s or the f prime, the derivative? Which one do you prefer? You don't care? That's fine. Okay. So let's try to write it in the form of del u del s. So first of all, u is a function of how many variables stated in this form? So if I write like this is, I don't know, a and t. How many variables did I have? How many variables did I have now? 2. Now differentiate u with respect to s. I can differentiate u with respect to s and with respect to t. So do I use a d by dt or a del in this case? Eh? How many variables is k? K has 2 variables. So if I were to say this, del u by del t, and I have another derivative which is del u by, you can differentiate u with respect to t and u with respect to s. Okay, you've chosen your variable you need to differentiate with. You've chosen t. Then what is s? S is a, how do you treat s when you differentiate with respect to t? Constant. You go back to the original formula. What is del u by del t? S is constant now. How do you differentiate if s is constant? You want to differentiate with respect to t, while s is constant, right? How do you differentiate this? I need del u by del x, right? After that, what do I need? To differentiate x with respect to? You always need them to cancel. Talk, they cancel, what do you get? Del u del t. Now you have another argument. What's the other argument? You differentiated the first argument plus del u del y. Are we good here or not? Is it clear? You held s constant. S is constant now, and you do the derivative with respect to t. So you differentiate u with respect to the first argument. I mean, let's write it in this way. I want to write it k at t is u, so k at t. U at t and g at t. Okay, so what is ks at t? Anybody can help me? Sure, but I want in terms of derivatives. In terms of derivatives. Let's look at this. Everybody, let's look at this. You want to differentiate this with respect to s, so we treat t as constant, right? What do you do here first? You differentiate this one with respect to s. So this is just fs st. Okay, you differentiated the first argument with respect to s. What does the one variable chain rule tell you? That you need to differentiate u with respect to what variable? To the first variable. Very good. So it's u1 plus, who can help me with the second one?
G S S T.
G S S T, very good. Derivative of G with respect to S S T times what? U2. Is it clear? Is it clear, guys? Is it clear? So, if you fix in this case, fix S, or fix T and differentiate with respect to S. So T is fixed. What do? Differentiate this one with respect to S, take it out. The derivative of U with respect to the first argument applied at these two, plus differentiate the second one with respect to S, times the derivative of U with respect to the second argument applied at these two. Okay, so this is del U by del T. I mean, let me write it this way. What is del U by del X? By del U by del X, sorry. It's just del U del X. Del X del S. Plus del U del Y. Del Y. Okay, now what is the derivative of K with respect to T? ST. Who can help me? Hasn't spoken today. Who volunteers? Yes?
ST,
very good. So the derivative of S with respect to T, yeah, times?
and then here it's UX,
UX, sure, UX is equal to U1, very good. So I'll just put U1 to stick with the notation, thank you.
FST, GST.
Awesome.
So GT, ST. And then the thing is to FST.
Awesome. Thank you. Okay. Now do problems. Let us do problems. Okay? Is this clear? I'll keep these here, and then maybe we can draw a graph. afterwards. Okay? We can draw a graph how to explain this. I mean, you know, did you see graphs in probability? Did you ever take probability? Did you draw trees in probability or not? Okay, so it's the same idea here. So suppose I have, I'll do it here. I have u, it's a function of x, and it's a function of y. Okay? U is a function of x and a function of y. X itself is a function of what variables? S and t. Y itself is a function of what variable? S and t. Okay? Now, here, any branch is this derivative. The derivative of the top with respect to the bottom. So this is del u del y, and this is del y del t, del y del s, del u del x, del x, del s, del x, del t. Now you want u with respect to x. And how many ways can you get from u to s? And you add them all up. How many ways can you get from u to s? 2. So it's u x s, and then u y s. You multiply these two on the same path you multiply them, and then you multiply these two and you add them. Okay? This is like probability. Have you seen probability, something like this? No? You've seen something like that, probability? You have taken probability, but usually the 3 is reversed, like you reverse the 3, right? You've seen that before? Yeah, I think so. So I mean, in how many ways you can get to so if you take the path u, y, s, what do you get along this? You get del u, del y, del s, plus del u, del x, del x, del x. Okay, and this is just del u, del x. Just u. Okay, this is one way of seeing it. I don't think it's very, for me at least, not very, very helpful. And so we can do it in 3 or 4 variables, but now let's focus on 2 variables, and let's start doing problems. So we start going hard from the beginning, or we go easy and then harder? Easy and then harder. Okay, great. Fine. N equal 1 and t equal 1 is this. If x minus y to the 5, x is x squared t, and y is x t squared. Did you understand this previous part or not? Are we good with the previous part? Yes or no? We good or not? Derivatives, are we good with this? So let's see. I need to differentiate del z by del s. Who can help me? What is del z by del s? Again, if you feel the graph is good, so z is a function of x and y is a function of s, x is a function of s and t, and y is a function of s and t. How do I differentiate this? What is del z del x? Every guess? Del Z, yeah, okay. Very good, yeah, from you.
Del V over del X times del X del S is del V del Y del times del Y del X.
Awesome. Are we good here? What is del Z del X? 5 times x to the minus y to the fourth, right? Times, what is del x del x? Who wants to help me? Del x del s is what? Is what? Good. Very good. Plus, what is del z del y? Did I make a mistake somewhere? Is there a mistake somewhere?
No, we're just wondering if it was an S or a 5. That's S.
There. Oh, yeah, here. Oh, shoot. Okay.
No.
5. I don't know. Let's change it actually. 7. Let's change it to 7. And here put it 6. Oh, sorry, 7. And here's 6. Okay. That guy, this one? This one? Okay. Yeah, S and 5s are usually on the. Yeah. Anyway, you can see that my handwriting is not there. Not there. Yeah, what is del Z del Y? So it's minus 7, right? Times, what is del Y del X? Del Y del X is what? Is squared. Okay, now if del Z del at t equal 1, s equal 1, what do you get? What is x? If t is equal 1 and s is equal to 1, x is equal to 1, y is equal to, this whole thing goes to 0, right? Del Z del, let's see, del S, oh man. Okay, is the chain rule clear or not? Everybody, is it clear? Is it clear? Any questions about it? It's very important. You will get questions on the chain rule on the final exam, 100%, like guaranteed. Should we do a few more? Let's do a few more. Well, I mean, let's find out that del T, but I mean, let's change it. Log 3x plus 2y. What time is it? I have 10 minutes left. 20 minutes left. 18 minutes. 18 minutes. Okay, here there are no 5s. If you're confused between an S and a 5, it's an S. Okay? So Z is a function of how many variables? In this case, so Z of S and T, right? So how do I need to do this? Del Z by del S is equal to what? Everybody. Who can help me? I don't want the answer, I just want the formulas. So someone who hasn't spoken today, by preference. Who hasn't said anything today and wants to speak? Yes. Del Z del X, del X del Y, del Z del Y, del Y del X. Are we good here? Everybody, are we good? Is it clear? Just say yes out like. Yes. Okay, very good. What is del Z del X in this case? Let's do it quickly. U prime over U, right? By keeping, so it's 3 over 3x plus 2y times del X del S. What is del X del S? Everybody, this is sine t, right? Plus, what is del Z del Y? This is 2 over 3x plus 2y. And what is del Y del S is minus t sine t. Okay, now what is del Z del T? Who can help? Who can volunteer for del Z del T? Del Z del T. Who volunteers for del Z del T? Someone who hasn't spoken. Yes, sir.
So it should be I z over I x times I x over I t.
Just a second. Del Z del X. Very good. Then del X
Over I t.
Yeah. Plus.
I z over I y over I t.
Awesome. Thank you very much. So let me do this. Del Z del X. What is del Z? Well, I have it already, right? Wait, what? Yeah, I have it already. It's 3 over 3x plus 2y times what? Del x by del t. What is that equal to? It's x cosine t, right? Plus, what is del t del y? Del t del y is 2 over 3x plus 2y times del y del t. What is del y del t? It's just cosine x. Let's do one more. Let's do one or two more. A couple more actually. Okay. Are we good? Fine. Del Z del Z and del Z del T. What is Z? Let's pick an answer. Z is e to the r theta. R is mt. Oh man, this is gonna be a bad one. R is mt. Oops. And theta is square root of st squared plus t. That's fine. Okay, so Z is a function of what two variables in this case? Z is a function of what two variables? R and theta. So let's draw this. Z, R, and theta. Theta and R are themselves a function of what two variables? S and T. Okay, and this helps. Okay. I want someone to help me, I want to volunteer, preferably who hasn't said anything today, to help me out by finding del Z del S. Let's go. Who wants to participate and hasn't said anything today? Yes, sir.
You want just the formula?
Yes, the formula.
Del Z del S is gonna be del Z del R times del R del S.
Del Z del R del S plus
Plus del R del theta.
Plus del Z del theta. Yeah.
I need del theta del S.
Great, thank you. Del Z del R, what is del Z del R? Let's do this. Del Z del R is e to the R plus theta, right? Del Z del theta, what is that? It's minus e to the R sine theta. Awesome. Del R del S, what is del R del S? Del R del S is T. And del theta del S is, what is del theta del S? Is S over square root S squared plus T squared. Can you guys plug them in here? Or do I need to do it? Do I need to write them down next to each other? Do I need to write them down next to each other? Or that's fine? That's fine. Okay, I want someone to help me by del Z del, what's the one I'm looking for? I look for del Z del R, or del Z del S, which is the other one I'm looking for? The interesting one, del Z del T. Who volunteers to help me with del Z del T? Any volunteer who hasn't spoken today? Yes?
Del Z del I.
Yeah?
Del R del Z.
Awesome.
Plus del Z over del theta. Del theta over.
Okay, so let me just compute del R over del T. What is del R over del T? It's S. And del R and del theta over del T is T over. How much time do we have left? 5? 10. Okay. Great. Okay, so maybe this one will take a bit more than 10 minutes, 11, so I kindly ask you just to be patient, okay? Just one more minute is not gonna, it's not gonna. Oh, by the way, today I have from 2:30 to 4:30 I'll be at your service if you guys have questions. If you don't have questions, I'll just do nice exercises, actually, like very good exercises. So I encourage you to attend, okay? So you can see this as a review session for the winter. I gave the room. It's Burnside 1214. The capacity is around 40 students. So all of you here can fit. I think, well, I think you have a bit more than 40 here, but I think we can fit. Yeah, so I'll just do exercises. Okay, let's do this. Suppose f is a differential function of x and y. Let GUV be equal to f. This is from the book. This is all from the book, by the way. Okay? Who wants to help? So what is fx at 0, 0? It is 4, okay? We all can read the table? Yeah. Okay, who wants to help me? How do I find GUV? Who wants to help us finding the derivative of GUV with respect to u at 0, 0? What do we do? Everybody, what do we do? It's the train rule, isn't it? We agree it's the train rule or not? Yeah. Who wants to help? SOS, who wants to help?
That cosine theta or
Cosine V.
And sine V is what?
V. Well, I mean, all of them are thetas or all of them are V. Doesn't matter. Okay. Who wants to help? How do I differentiate? So which variable I want to differentiate with respect to u first, okay? How should I do it? It's the same chain rule. It's actually the same chain rule.
It's the derivative of e to the u times v.
Okay, very good. So let's very good. Thank you for GUV. What is that? It's the derivative of e to the u plus sine v with respect to u, which is, so let me write this here.
E to the u.
U times what?
F u. Oh, the whole thing.
Are you sure it's f with respect to what variable? F sub u or f sub x? Okay? F sub x. Plus what?
E to the u cosine v. Also with respect to u.
Yeah.
F y.
Okay, so let me just differentiate this. So what is GUV? Derivative with respect to u, it's e to the u fx. Okay, plus e to the u fy what? E to the u plus sine v. E to the u plus cos v. Now, at what point do I want the derivative? At what do I replace u and v by? 0, 0. So what do I get? GU 0, 0. What is that equal to? Is that good? GU 0, 0. What is that equal to? So GU 0, 0. This is just 1. Fx at what point? 1. Very good. Thank you. Plus 1. Fy at what point? At what point? 1. Are we good here? What is that? 2 plus 5, right? It's 7. What time is it? We have 5 more minutes or no? 1. That's fine. Next time you only 1 minute. Okay? You guys can leave. We're done now. I'll just take 1 more minute. No, I'm kidding. Okay? Any questions on this, please?
ask